Welcome everyone, and thank you for attending today's webcast, Autodesk Inventor versus Fusion 360. Our presenter today is Bon Rhee. He's a solutions engineer with Hagerman & Company. We're also joined on the line by Gary Bergero. He's a solutions engineer with Hagerman & Company, and he'll be on to field questions throughout the presentation. You are in listening only mode, but if you have questions during the presentation, you can type those into the question panel that is located on the right-hand side of your screen, and they will be addressed throughout by Gary, and at the end, Bon will cover some as well. As we close down the session today, you'll be prompted to fill out a survey, and we do ask that you take a few moments to fill that out. Additionally, all registrants will receive a follow-up email containing a link for the recording of this presentation. Before handing things over to Bon, I'm going to ask a polling question. Let me just open it up. And the first question is, what CAD tool are you currently using? I'll give you a few moments to select. Okay. I'll give a few more minutes to get a few more votes in here. It looks like we are at 71% Inventor right now. About 75% Inventor users. The rest are mostly AutoCAD. Okay. So I'm going to close that. And with that, I will hand things over to Bon.
Hi, great. Thanks for the intro, Ashley. Good morning, everyone. My name is Bon Rhee, and I am a manufacturing solutions engineer here at Hagerman. I support the sales team and our customers in pre-sales and post-sales solutions. I attended Rutgers University in New Jersey, where I studied mechanical engineering. And I've been in manufacturing for over 20 years now, and about 8 of those years have been with Autodesk value-added resellers. My first exposure to CAD was AutoCAD version 9 in the late 80s, and then I made the switch to Inventor in 1999 with Inventor version 5. So, the agenda for this webinar. So at Hagerman, we've been getting a lot of questions recently on Autodesk's product offerings, their names, and their particular branding. Autodesk products have similar names and functionality, which has been causing confusion. So the purpose of this webinar is to clarify some of the questions we've been getting. Questions like, what is A360? What is A360 Drive? What is Fusion Team? And one of the more common questions is Fusion 360 better than Inventor? So I hope this webinar can answer all those questions for you and more, and help you decide which product can best suit your needs. So as I mentioned in the previous slide, I'd like to clarify some of the product offerings by Autodesk. The first thing is A360 Drive, which is a cloud storage offered by Autodesk. It's like Dropbox. It syncs with your desktop, and you also get 5 gigs for free. A360, which was also known as A360 Team, has now split into 2 cloud-based collaboration products. BIM 360 Team for the AEC industry, and Fusion Team for the manufacturing industry. And the reason for this slide is to introduce you to Fusion Team, which is what you will need to access Fusion 360 through a browser. And Fusion 360, as some of you may know, is a cloud-based design, data management, collaboration, visualization, manufacturing, and simulation tool that works on both Mac and PC. And these products should not be confused with another product that's coming soon and currently in beta called Autodesk Drive, which gives you a central location on your computer for the products I just mentioned. So let's start with Fusion Team. Fusion Team is a standalone product that comes free with your Fusion 360 entitlement. Fusion Team is a cloud-based collaboration tool accessed through a browser like Chrome or Firefox. There is a quote-unquote universal viewer built into Fusion Team, so it can be used with Fusion 360 or other CAD products. But in order to edit existing files in Fusion 360, you'll need access to Fusion Team. There is a desktop version of Fusion 360, but Fusion Team allows you to interact directly with Fusion 360 models and drawings in a browser. So Fusion Team will also allow project members and manufacturing teams to centralize the project information. And since it provides an online workspace, you can communicate as if you were all in one location. Any of the project members can view, comment, redline, and mark up current designs or previous ones for all team members to see. It can also simplify the review process and eliminate the need to email or file transfer large sets of data. Another nice feature is to have reviews in real time. You can have live review sessions with built-in browser sharing, similar to GoToMeeting or TeamViewer. So there are two versions of Fusion Team. You can have a personal hub or a company team hub. The personal hub can have one team member, but the company or team hub can have unlimited team members. A team member is basically someone that has admin rights to the entire hub. Personal hub can have one project, but the company or team hub can have unlimited projects. And both hubs can have unlimited contributors, which means you can have unlimited people working on the project. And let me note that this licensing is subject to change in January of 2018. Right now it is unlimited, but that is definitely going to change when they get the Fusion Team a little more tightened up. So both types of hubs can access Fusion 360 through a browser. And just want to have a little demo of Fusion Team now. So let me get out of PowerPoint real quick. And I'll bring over the Fusion Team window. So here's the Fusion Team window. I'm currently using it in Google Chrome right now. And through this icon here, you can see my different hubs. This is a team hub I am in now, but right here is a personal hub that I had mentioned earlier. And through Fusion Team, you can see the activity window here that shows everything that I've done and what other members have done. And these are the current projects that I have access to in this particular hub. And inside Fusion 360, whoops, didn't mean to click that. Here is what Fusion 360 would look like with just a regular CAD file in the the Fusion Team viewer would look like for a particular CAD file. And you can see it's a little different than accessing Fusion 360 through the Fusion Team website, because we also have the desktop version. So this window here is a desktop version. You can see it's a little more full-featured, has more features than the browser-based version, which is a little stripped down. Okay, so to show you the two differences there. And basically, the desktop is the full version. And you can see here the same projects that I have access to from the Fusion Team website. All right. So let's get back to the PowerPoint slides. Let me bring this back up. Hold on a second. Okay. All right, so moving on to Fusion 360 itself. I'll get into some of the features of Fusion 360 and Inventor later, but first let's look at kind of the big picture. So there are two versions of Fusion 360, Fusion 360 and Fusion 360 Ultimate. Fusion 360 is a parametric CAD tool that combines industrial and mechanical design with collaboration in one easy-to-use and affordable package. Your designs are stored in the cloud, so you can access your designs at almost any time, from anywhere, from your Mac, PC, or mobile device. And this smaller image right here on the right is actually a screenshot from my iPhone. And with an integrated CAM tool, you can prepare your designs for machining or even prepare it for 3D printing. And since new features and options are added with automated monthly updates, makes it pretty much effortless to maintain. And the main differences between Fusion 360 and Fusion 360 Ultimate are the 5-axis machining capability and the more advanced simulation package. The features in white up here are included with Fusion 360, and Fusion 360 Ultimate has all the features listed in white and blue. The free startup enthusiast licenses allow you to access Fusion 360 Ultimate for 1 year. You can use this license if you are a small business making less than $100,000 per year, or if you're a hobbyist using Fusion 360 for non-commercial purposes. And the educational entitlement includes students, faculty, and qualified educational institutions for a period of 3 years. So let's get on to the Inventor products now. So let me start by saying that just regular vanilla Inventor is no longer offered by Autodesk. Your only options now are Inventor LT and Inventor Professional. And as most of you probably know, Inventor LT is just also known as Inventor Lite and is a very light version of Inventor Professional. And basically, Inventor Professional does everything Inventor LT can do and much more. It is probably the most complete 3D parametric modeler offered by Autodesk for the manufacturing industry. And I know some of you may be thinking about Revit, but that's for the AEC industry. And the most obvious difference between these two products is that assemblies are not supported in Inventor LT. Okay. So some of the hardware requirements for Fusion 360 Ultimate and Inventor Professional. So these recommendations that you see on the screen are by Autodesk and not myself or Hagerman. If your computer looks anything like this, it probably won't run Fusion or Inventor, and it's probably time to upgrade. If your parts are complex and your assemblies contain many parts, by many I typically mean more than 1,000 parts, then you'll want a beefier system than the specs shown here, and you'll probably have to use Inventor. If you have a newer computer or are looking to buy a new computer, the specs will most likely be similar to the Inventor column, so running Fusion 360 on it shouldn't be an issue. Looking at the operating system for Fusion 360, it can run natively on Mac OS or Windows, but Inventor definitely needs Windows in a native or virtual environment. So there is an asterisk for the internet required in the Fusion 360 column because it can run in offline mode. So you can work on new parts, but you will need that internet connection to get to Fusion Team and your existing CAD files. Whereas Inventor files are stored on your local network or your local computer. My personal preference would be a minimum of 32 gigs of RAM with a solid state drive, or even better would be a PCI Express solid state drive and a video card that isn't shared with the motherboard. So now that I've introduced Fusion 360 and Inventor to you, let's get into the nuts and bolts of this webinar and start looking at some of the similarities and differences between Inventor Professional and Fusion 360 Ultimate. Let me add these features are in no particular order. They're both equal in freeform modeling and direct modeling tools, but Inventor does have a slight edge in its parametric tools and the sketch environment. However, Fusion 360 has an edge in simulation because, like Inventor, it offers it offers static stress and modal analysis, and it has additional tools like event simulation and thermal stress. Fusion 360 also has the upper hand in CAM because it is built into the product, and Inventor does not offer any CAM solution out of the box. However, last month, Autodesk did add a couple of add-ons for Inventor, Inventor HSM, or Inventor High-Speed Machining, and Nastran InCAD to the product design and manufacturing collection. So these two products will probably tip the scale in Inventor's favor. Both also offer shape optimization, although in Inventor it's called Shape Generator. So at this time, I'm going to show you a quick little demo of shape optimization in Fusion 360 Ultimate. So let's get out of this. Let's bring up Fusion 360. Okay, and again, I'm in the desktop version. You cannot do this in the browser version of Fusion 360. And basically, we're going to look at shape optimization, and it will take a part, and we can add loads and constraints as its input. And the shape optimization tool will remove material for rate reduction, for rate reduction goals that you can specify. And the result will be a part that uses less material and is at least as strong as the original design. So to start the simulation, I'm going to go to the Model tab here and click on Simulation. And I'm going to start a new study called Shape Optimization. Okay, and once I do that, I'm ready to start defining our material, constraints, loads, and mesh size. So like most Autodesk products, or pretty much all Autodesk products, you can start in the left side of the ribbon and start working your way over to the right. So the first thing we're going to look at is material. So I can use the material that's in the model, that came with the model, or I can use any of these other materials. For this particular case, I'm just going to use the original material, so we'll leave that same as the model. Okay, next I'm going to apply some constraints. So in this case, it's going to be pin constraints. And I'm going to select the interfaces of here and here. Say OK. So working my way over to the right, I'm going to apply load now. I'm going to apply load to the location where we expect the grip arm to experience a force, and that'll be that face. And just change the value to 500 newtons. Okay, I'm also now going to use the shape optimization tool, but I need to find which parts of the material the optimizer shouldn't remove. So in this case, I don't want to remove material around these pinholes. So I'm going to select here, and I can use the grips to change the size, or I could just enter a value. I'm going to enter 8 millimeters. And I want to preserve the region around the smaller pinhole. That'll be 6 millimeters. So I'm also going to adjust the shape optimization criteria for this particular part, meaning I can give it a value of how much of the percentage is going to be the target mass. So right now, the default is 30%, but I'm going to go for 40%, and that'll be 40% of the original mass. And it will, the tool will still try to maximize the stiffness of the part. I'm also going to put in a symmetry plane because our model is symmetric about the thickness of the part, or the XY plane. And we want the new lightweight optimized part to retain the symmetry. So I am going to select the XY plane. And by selecting symmetry plane, essentially it will speed up the solution time also. All right, so now we're going to go to the mesh settings. And for the mesh setting, I'm going to go to with an absolute size of 3 millimeters. So generally speaking, the more we refine the mesh, the closer the solution you get to its objective. So what you can see by this green check mark here, we are ready to run the simulation. And I can click Solve to start producing the optimized shape. So Fusion 360, Fusion 360 Ultimate, the shape optimization tool, runs in a cloud. This means the optimization isn't done on your computer like Inventor, but in the cloud by Autodesk computers. So you'll need to use what are called Autodesk Cloud credits. And you can see when I use the local button here, there is no option, and the solve isn't even available to me because this feature isn't available. So it looks like hopefully Autodesk will be adding this option in the near future. And the advantage of a cloud solve is that you won't be using your computer's processing power, because solving a simulation can take anywhere from a few seconds to even many hours. So basically, the cloud solve lets you perform other tasks while the simulation is running. But again, the disadvantage is you need to use cloud credits. If you log into your Autodesk account, you can see how many cloud credits you have, as well as purchase more cloud credits. So I could click Solve here, but for the sake of time and this webinar, I'm just going to close it and go to one that I've already created. So here's the part after the simulation has been run. And I can excuse me. I can manipulate the slider. You can see the model changing. The mass of the model is changing by how much the mass ratio here that I'm targeting. So after I'm satisfied with the results, all I do is promote the results back to the model environment, which I've done already here. And you can see the sketch I've done with the mesh results as a reference. So I basically have sketched around the mesh there. And once I'm done with the sketch, I can update my model. So I think that's pretty neat there. And the best thing to do is probably run the simulation again, or run some other analysis on it just to verify your results. Okay, so let's go back to the PowerPoint slides. Okay, let's go to the next slide. So here's some more features we can compare. I think the sheet metal environment is better in Inventor because there are a few more tools and commands. Also, Inventor has a clear advantage in drawing annotations, styles, and the entire drawing environment as a whole is just superior. Rendering Inventor is built in with Inventor Studio, and again has a few more tools than Fusion 360. Whereas Fusion 360 would be using Autodesk Cloud Rendering Service with those cloud credits again. And when it comes to learning Fusion 360 or Inventor, the basic sketching and basic 3D modeling features are very similar. But I'd say Inventor has a steeper learning curve because there are way more features, add-ins, and more environments to learn. And as I mentioned earlier, if you are in the right demographic, Fusion 360 could be free, whereas Inventor has no free option. Otherwise, the price difference between Fusion 360 Ultimate and Inventor Pro is only a few $100s and not thousands of dollars as you might think. So here are some clear advantages and features Inventor Professional has that Fusion 360 doesn't even offer. And I don't think I even have every advantage listed here. I'm not going to go through each item, but a clear differentiator and everyday tool is the standard library, or as most of you may know, also called the Content Center. And with tools like shrink wrap and derived parts, Inventor makes it much easier to work on large assemblies. And another important everyday tool which Fusion 360 doesn't offer, which I will demo next, is the table-driven parts like iParts, iFeatures, and iAssemblies. Table-driven design, or sometimes called configurations in another competing product, is the ability to manage multiple parts of families in one part file. Another exciting new feature, what do I have it listed here? Ah, there it is, okay. Another new feature that was added in 2016 and has improved the last 2 years is a product called AnyCAD. And with release 2017.4, you can now reference other CAD file types like SolidWorks, ProE, CATIA, STEP, and more. And you can even reference newer and older Inventor models into your current Inventor model and keep the associative connections. So basically, in other words, you can import any one of those file types I mentioned into your Inventor assembly, and if the associated file gets updated in its native CAD application, your Inventor assembly will reflect that update. So that's a pretty cool tool, I think. And for this webinar, I just want to show you table-driven design, or iParts, and Inventor. So let's get out of this one more time, and let's jump to Inventor real quick. Okay, so what I've done here is I exported the gripper arm from Fusion 360 as a step file and imported the file into Inventor. So in my sketch, let me get into the sketch here. In my sketch, I dimensioned this thickness, but named it width. I guess I could have called it thickness, but I named it width, and I referenced these other dimensions back to that dimension, so that if I change this dimension, those other dimensions will update accordingly. And also, I shared my sketch so I could make these other extruded cuts here. And so I could manipulate each one of these features and suppress them independently of each other. I also have fillets in my model, and I renamed that fillet RAD. And the reason I renamed these two is because when I enter the iPart table or the iPart environment, these named dimensions will be automatically populated into my table. So let's do that now. I'll go to the Manage tab. I'll go to Create iPart. And as I mentioned earlier, you could see width and fillet rad are automatically populated in my table. And all I need to do is right-click here and insert rows to start adding those family members. And I can also control suppression here. So I'm going to add the middle cut feature, the slot cut feature, and the right cut feature. And basically, the suppression is binary, so I can use terms like compute or suppress, or even ones and zeros. So let's just do a combination of that. I'll put 0, which is like a suppress. And I can even type in suppress here. So let's try, let's suppress this one, put a 0 here. Let's suppress this right cut from this particular member. Let's suppress this one. And let's suppress the slot cut here as well. And we can also change these values. We'll go 5, 6, 4 for that width, for that thickness. And 5, and we'll go back to 4. And we'll even change the radiuses, the fillets there, to 4, I don't know, 5, 6, 5, then 4. Okay, I'm just going to click OK now. Let me suppress this to clean it up. And if I go into my table now, you can see the different members I've created. And if I click on each member, you'll see my model update according to that table I just created. And you can see in this particular member, these 3 features are suppressed. And then the third member, only the slot cut is suppressed. And you can also see the thickness is changing where applicable. All right, so that thickness has changed as well. Okay, so let's get out of Inventor and back to the PowerPoint slides. Let's see where we leave off. Okay. And we end up here. All right, there we go. So you should consider using Fusion 360 if most of these features apply to you. In other words, if you need a basic cloud-based collaboration solution like Fusion Team, and you work on small assemblies and less complex models and cost is an issue, then you should consider Fusion 360. Or if you want a CAD/CAM solution right out of the box, or if you want something to run natively on your Mac, then Fusion 360 could be for you. You should consider Inventor if you fall into any one of these categories. So if you are working on large assemblies or complex parts or interfacing with other companies using a CAD tool other than Inventor, or need add-ins like tube and pipe, frame generator, weldments, or if you export your Inventor models to BIM or Revit, then Inventor is likely should be your choice. And frankly, Inventor Professional is probably the more well-rounded, fully featured, and mature product. If you need a complete parametric modeler, you really can't go wrong with Inventor Professional. However, if you choose Fusion 360, at some point you may realize there's a feature or environment that you need, but just isn't in Fusion 360, but is in Inventor. Okay. All right. To sum up, if you're still not sure which product you need, of course, the easy answer, and easy for me to say because I'm pretty good at spending other people's money, is just to buy the product design and manufacturing collection, which includes both Fusion 360 and Inventor and much, much more. As I mentioned in a previous slide, about 2 months ago, Autodesk added 2 new products to this collection. It added Nastran in CAD and Inventor HSM. And with these 2 additional add-ons, it really makes Inventor a full-featured CAD, engineering, simulation, and CAM product. Okay, and for more information, you can go to our website or call the number on the screen now. If you go to the training link, you can see our open enrollment classes for the AEC and the manufacturing industry. Or if you prefer, we can also we also offer custom classes. We can tailor for each company or individual. And please don't forget to go to YouTube and search for Hagerman & Company and subscribe to our channel. And of course, we are also on Facebook and Twitter. So that pretty much ends my PowerPoint. And we can get on to any questions that you guys may have. So Gary, did we get any questions coming in while
yeah, we got questions regarding Yeah, cloud credits for rendering it's 1 cloud credit per megapixel. So we answered that. There's a current question. Since you had the PowerPoints on small assemblies versus large assemblies, the current question is, how would you define small assemblies? And I think what he might be referring to is any idea of in Fusion 360 how large of an assembly is going to work well. I think that's more related to his question.
Sure. So as I mentioned earlier, so the large assembly is, I'm going by Autodesk definition again, and that's a large assembly. They define it as 1,000 parts or more. But again, those 1,000 parts, if they're very simple, it should be okay for Fusion 360. So for example, an assembly with 500 surface models using surface tools is probably going to be more complicated than a 1,000-part assembly with just, basic cubes. So you definitely have to take that into consideration. How complex the models, the parts are, is definitely a factor, as well as the size of the assembly or the number of parts in the assembly. But generally speaking, large assembly means anything over 1,000. So that in turn would mean small assemblies are anything less than 1,000. But again, please consider the complexity of each part as well, because that will definitely make a difference on your computer.
Great, thanks.
So any more questions?
Question on the free licensing for startups just came in.
Sure. How come I can't see the questions here? That's pretty odd. All right, so let's see what the question here is.
I'll read it to you, Bon, if you can't see it. Can you tell us more about the free licensing for hobbyists and startups? I was on their website yesterday, and it's basically a form that you fill in, and Autodesk would probably contact you just to verify that you're a startup and what kind of business, and so it's probably a form to be filled in. Bon, that's what I saw yesterday. I don't know if you can add anything to that.
Yeah, so what you'll need to do is you'll definitely need to download the trial version first, and you'll see the I think one of these icons changes. So is it job status or like here? If you go, you'll see an option here in the trial version to turn it into a I guess a permanent entitlement. And again, this option will change, and there are forms to fill out. Autodesk will probably ask you some questions if you want free software, but I believe there's a page. Let's see if I can find it. God, I know I had it earlier.
Yeah, it's on the Fusion site to get started.
Yeah, if you just do a search for like Fusion 360 free entitlement or free licensing for hobbyists and startups, it should come up.
Yeah, it will.
Yeah, and then it's pretty detailed. Everything you have to read. I don't want to go through every little point in there, but here's actually how to activate it on this page here. And again, all I did was search for Autodesk Fusion 360 for hobbyist, and I'll give you more details on how to activate it and how to get the free version.
Okay. You got one more question coming in. I thought that Simulation in CAD is now part of Inventor Professional. I think you were mentioning the new announcement about what they're doing with Nastran in CAD. If you can mention that again.
Yeah, so Nastran in CAD, that simulation is not a part of Inventor Professional, but a part of the product design and manufacturing collection. So if you buy the collection of products, you will get Nastran in CAD. But if you just purchase Inventor Professional, then Nastran in CAD is not included. So basically, you need the product design and manufacturing collection to get Nastran in CAD. And you also get Inventor HSM as well. So that is in this slide here. Whoops. Right, these are all the products in the collection, and these two are just added. But again, you need the collection, not just Inventor Professional.
Great.
All right.
You got one more question. Can Fusion 360 open Inventor files? I believe it says so. I know that Fusion, it's the they use the an upload command. Yeah, go ahead.
Yeah, so Inventor can open Fusion 360 files natively. The Fusion 360 file is like an F3D file, and Inventor does not have that option. So you will need to use a translator between the two. That's why I did in my demo earlier. I used step file to make that translation, and hopefully they will have a way where they can Fusion 360 and Inventor can open each other's files natively, just like Inventor can open SolidWorks files. Actually, let me take a quick look here. I don't think it can. So if I go Inventor, yeah, you can see Fusion 360 still isn't in the list yet, which is a little strange, considering that they're part of the same family of Autodesk, right? So to answer your question, no, not at this time. Okay. All right. Any other questions? Oh, all right. I just clicked here. I see the questions now. So Larry's asking 1,000 unique parts or 1,000 occurrences. So I think Autodesk referring to probably 1,000 occurrences. So they even need to be unique, but 1,000 occurrences would be my guess. I can't be 100% sure, but I would have to guess 1,000 occurrences. All right. So the next question is, when using shape optimization, can you link the results to the model? And can you set up a sensor to warn you if you remove too much material? There is no sensor warning you to remove too much material. It's just a visual indicator from the mesh. And so I don't know what you mean by link, but you can just kind of use an overlay. It's not going to be associative where if you update the optimization, your Inventor model won't update accordingly, but again, it will be just a visual reference that you have back from the simulation file. So did I answer your question, James? Okay, if not, James, go ahead. You can reword it. Okay, great.
Yeah.
Any other questions out there? We'll give you guys a few more seconds to think of a few more questions, and if not, we can turn it back over to Ashley. So let's give everyone another minute or two here.
Okay, thanks, Bon, for the presentation. If you think of additional questions that you have later on, you can simply reply to the confirmation or reminder email you received from GoToWebinar. We can get those to Bon or the correct party to get your questions answered. Once again, if you could take a few moments to fill out the short survey, we would appreciate it. It will just automatically appear as we close down today. If there's nothing further, and it looks like there's not, I'll just thank everyone for attending. Thanks, Bon, for the presentation, and have a great day.
Great. Thank you, everyone. Thanks,
Thank
Karen.
you.
Thanks, Ashley. Bye, guys.
Sure.
Bye.
Bye.